Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of low barrier hydrogen bonds. A typical hydrogen bond is weak and has about 10 to 30 kilojoules per mole and has this basic orientation in which one of the oxygens is referred to as a donor and the other one acceptor. It will be covalently bound to the donor and not covalently bound to the acceptor. So the typical distance, as you can see, is 2.8 angstroms or 0.28 nanometers. And as the distance becomes smaller in between the heteroatoms, in other words, as it starts becoming more centrally located, you get this interesting phenomenon of what's called a low barrier hydrogen bond. And interesting things begin to happen. First of which is the bond order tends to decrease, making it more covalent in nature on both sides. So it goes from 0.7 to 0.5. This makes the stabilization energy higher. The hydrogen becomes more centered and the pKa's become more convergent to the same value. Okay, if you've got different pKa's, that's indicative of a normal H bond, but once they're pretty closely matched or similar, then that's indicative of a LBHB. So all of this leads to a decrease in the energy that the hydrogen must overcome to go from being covalently bound to this oxygen to being covalently bound to that oxygen. So it can pretty much be anywhere in between these two oxygens. So as a result, the O distance decreases, and now we get a bunch more energy being released in these hydrogen bonds. So in a gas phase, we have roughly this 100 kilojoules per mole, and then in the solution, we have the 60 kilojoules per mole. Why is this important? Well, when we form these low barrier hydrogen bonds, energy is released. That is the key. So what happens to us as biochemists, we can have these ordinary hydrogen bonds that are found in the membrane switch to a low barrier hydrogen bond. Let's say it's in an intermediate step or a transition state has been formed. We form this LBHB, and in doing so release a bunch of energy, and this released energy can help drive an unfavorable reaction forward. And it does this by lowering the activation barrier of that reaction. All right? So, quick recap. I'm not going to discuss a single well H bond. We're just looking here. This is typically what you see, in which the hydrogen's closer and covalently bound to one, and then the other one is not covalent. As you make the distance smaller between the heteroatoms, the hydrogen and the oxygen, then you decrease the bond order, you strengthen the bond. The pKa's for here, the pKa's for these two oxygens are very different. Here, they're almost exactly the same. Okay? So that LBHB formation releases energy. Enzymes use that energy to drive reactions forward. All right? I hope that clarifies things for you on low barrier hydrogen bonds. Thank you, and have a nice day.